Okay, guys, so we're back to page 41, like I told you on the last reading, because gravity and the electromagnetic spectrum were listed on the same page. So after gravity, then we're going to go to page 45, where we start with we're going to go to page 44 to see examples of gravity sections or gravity information. So gravity. Gravity is a force of attraction between two or more masses. Everything that has mass has gravity. The more mass you have, the stronger the gravitational force you give off. For example, Earth has more mass than the moon, so its gravitational pull is stronger. So it says right here, which planet based on mass in our solar system has the greatest gravitational pull? That would be Jupiter, because it's the most massive one. Sometimes we confuse, and I put here largest just because when we look at it, it is the largest and it does have more mass. But largest doesn't always mean that it has more mass. In this case, it does. Number 2, why do the planets in our solar system orbit around the sun? Because the sun has a greater mass than the planets. In addition, as the distance between two masses increases, the gravitational attraction between them decreases. So then we have an example right here. Which diagram below has the greatest gravitational attraction and why? Okay, so these two, we see object on the left and the object on the right, which are the same size as the object on the right, on letter B. Object on the left is bigger than object on the right, which is smaller. So they're the same size. But it's asking which one has the greatest gravitational attraction and why. Sample A, this one right here, has the greatest gravitational attraction because the two objects are closer together than on sample B. Here they're more separate, so the gravitational attraction is going to be greater over here because the gravitational attraction has to do with mass, and it also has to do with the distance between the objects. So we're on page 44. So I'm going to put it up here. And on page 44, we continue with gravity. Gravity is a pulling force that varies among objects. Consider the following models of the sun and planets, and determine which answer choice represents the larger gravitational force. Largest as in being the strongest. So then right here, we have comparison 1, A. So this is the one that has the largest gravitational force, then B, because the objects are closer. So right here, they're the same size, but this one's closer to this one, so there's more gravitational force right here than we see on B. Now on section number 2, A, again, okay, has more gravitational pull than B because the object is less massive. Okay, so then right here, this object is less massive than this one. So because of that, we're going to have a greater gravitational pull on A than we do on B. So we continue with gravity, and this is the bottom of page 44. It says gravity is the force that governs the motion of our solar system. No matter what kind of question there is, and if it has to do with our solar system and why are the planets in motion or in orbit, it's because of the gravitational pull of the sun, which is very massive in comparison to all the planets. So that's why it pulls them, it tracks them towards it. So then why is gravity important? Gravity is important because it keeps the planets in orbit. We do want to stay in orbit, right? We don't want to move away from the sun or be pulled away from the sun. What would happen to our solar system if there were no gravity? So then if there were no gravity, our planets and moons would move away from the sun. They would travel at the same speed and in a straight line. So this is page 45. It says the diagram below models Mercury and Venus orbiting the sun. So we have Mercury and Venus. Here we have Venus and we have Mercury. What force causes Venus to travel along a curved path instead of moving in a straight line, is indicated by the dashed line in the diagram? Remember what we said, if we didn't have that gravitational pull, then all the planets would just keep on going in a straight line and at the same speed. we don't do that because of the gravitational attraction between the sun and Venus, or the sun and the planets. So right here it says electromagnetic attraction. No. Gravitational attraction between the sun and Venus. I like that. So this one's no. Electromagnetic attraction. No. Gravitational attraction between Mercury and Venus. No. It's going to be between the sun, which is right here, and Venus, and the sun and Mercury. So then the correct answer is going to be letter G. So we're still on page 45 for question number 13. In July 1994, the comet Shoemaker-Levy 9 collided with the planet Jupiter. So they collided. As the scientists had predicted, to be able to accurately predict when a comet will collide with a planet, it is essential to understand. What is it that we must understand? Gravity, right? Remember that we said one planet, if it's more massive and depending on the distance, is going to attract the other. So then the composition of the planet's atmosphere, maybe that'll tell us how big it is or how massive it is. But no, the atmosphere is on the outside, right? Those are the gases, so no. The gravitational attraction that exists between all bodies, I like that one. The attraction of opposite poles, the poles don't have anything to do with it. In the formation of the comets, nope, we don't need to know about the formation, so this is not it. So then it is going to be the gravitational pulls of our bodies. So this is page 46. So we're going to look at the next question that has to do with gravity, and that's question 18. It says an image of the Earth, Moon, and Sun system is shown. So here it shows the motion of these three objects, the Sun, the Earth, and the Moon. The Moon remains in orbit around the Earth because of the force of, well, the Moon is closer to the Earth. That's why it orbits around the Earth. It's not closer to the Sun. If it would have been closer to the Sun, then it would be orbiting around the Sun. And actually, it's caught within the Earth's orbit, but in reality, it is also orbiting the Sun as it is going around the Sun with the along with the Earth. So then it's Earth's rotation. Nope. Moon's rotation. Nope. Earth's gravity. I like that one. And the Sun's gravity. No, it's not the Sun's gravity. Because the Moon is closest to the Earth, it's going around the Earth instead of going around the Sun. And this is the last question that has to do with gravity. And this is question number 2, still on page 46. A student makes a model of the Sun's Earth system by swinging a ball around her head. Using this model, the student is trying to explain how Earth stays on a path around the Sun. So here we have the ball, which represents the Earth. Here we have the hand, which represents the Sun. And this is the path, the orbit. The student explains that this path is the result of, I wonder if it's going to be gravity. It says the magnetic attraction between the Earth and the Sun. No, there's a gravitational attraction. The potential energy stored in the Earth that originated from the Sun. No. The gravitational attraction between the Sun and the Earth. I like that. The electromagnetic energy. Nope, that's not going to be it. So right here, just keep in mind, we say the correct answer is going to be H, but if we had no gravitational pull from the Sun, just remember that the ball would continue in a straight line and at the same speed. It's not doing that because we have that great gravitational attraction from the Sun. Thank you, guys. I'll go ahead and see you. And here the word is going to be our great solar system. And that's not a word, it's a phrase. So I'll be looking for that. Bye-bye, guys.